For a tutorial this week, you are required to create an interface and have that interface implemented in the fraction class. This is to prepare for the tutorial. You'll be asked in the tutorial to also create an interface and then implement it somewhere. So the interface that I'm asked to create is called measurable. So let's create that. So I'm going to open this up in Emacs. I'm going to create the interface measurable. So this is the same as when you're creating a class. You are creating it in a file called measurable, in this case measurable.java, and I'm just going to call it the interface measurable.java. I'm just going to make the font a little bigger so it will be visible on the screen. So the way that we create an interface, I'm making the interface public, and instead of the word class I'm having the word interface, and I'm giving it the name, which is measurable. So similar to a class declaration, and similar to it, we can create methods in there. In this case we want to create a single method, just one method called measure. I can specify the access. Public is the default here. By default it is abstract. This here returns a double, and getMeasure is the name that I wanted to give it. It does not take any arguments, and because this is in an interface and always an abstract class, I just ended with a semicolon, and this is it. This is all that I have to specify for the interface. So I can save this and I can compile this if I want. So I can compile measurable, and I now have it done. So the only thing that is now left to do is to take that fraction class that we created in week 6 in the lecture on Wednesday, and I want to update this such that it implements measurable. So instead of extends a certain class, we're saying that it implements an interface. I can just save this, and I can now compile both of them. And I should get a compile error because it says that the class fraction implements measurable, but the abstract method getMeasure is not implemented. It is an abstract method similar to if I have an abstract superclass, I have to implement its methods. Either I have to declare the class as abstract, or I have to provide the method. So I can add the method public double getMeasure. So I'm overriding the method now, and the way that I wanted to implement this is by returning the real value that associates with the fraction, or which is an approximation of this of the fraction. So what I want to return is the numerator divided by the denominator. One slight difference that I have to make here is that if I do integer divided by an integer, the result will be an integer, which depending on it's not going to give me a real number. So by converting the numerator to a double, I have a double divided by an integer, so it will give me a double back. So I can compile these now, and it should tell me that everything is okay, so it compiled. So let's test this. I'm going to create a main method in here. Public static void main, so that I can run and test this. So let me create a fraction. F.set numerator. Let's set this to 1. F.set denominator. Let's set this to 2 so that I get a half. And system.out.println. I can have f.getMeasure. So let's make sure that this here is actually computing the correct value. And run this. Java fraction. and it indeed gives me the correct measure. Now, one thing that I can do as well is, let me create a few of them. So let me create an array of 3 measurable objects. Measurable, let's make an array, and I'm just going to call this M, new, measurable. Let's create 3 of them, and let's do for means index is equal to 0, index is less than 3, I'm creating 3 of them. So let's create, actually let's just create 1 fraction objects. And I'm going to put this inside of my loop. I'm going to set the numerator in the loop so that I will set it to the index itself. So I have now that, actually I want to create 3 different fractions. And let's set M at index equal to F. And now let's print all of these up. So for measurable ms in M So for each of these measurable objects, I can print it to the console. So notice that I created 3 fractions which are measurable objects, and I put them into this array of measurable objects. And I am simply now printing the real value that is associated with each of them, 0, 0.5, and 1.0. So a basic example on how to work with interfaces and how to polymorphically access things that implement a certain interface.